Welcome back. It's section 3, and like I promised in the previous lesson that we're going to go on and talk more about these organic molecules. We're going back to look at alkanes. There's still a few things that we need to talk about. The first thing is that we need to know that these are saturated hydrocarbons, and they are saturated because they've got single bonds between carbon atoms. Something that is saturated has got enough. It cannot take anything more. Okay, so it's saturated. It's like a taxi full of passengers. It can't stop for more passengers. It is saturated. So that's basically what that term they mean. And within these alkanes, we've got methane as the first one with first carbon atom. So that's what we have, right? Then we have ethane. This will have 2 carbon atoms like that. You would put your hydrogens there. Propane, 3 like that. So the chain is growing and growing as we move on. Butane, this one would have 4, and the chain, like I said, grows and grows as we move on. So you have your hydrogens like that. Please never ever just have a line to represent your bond without putting in those atoms that are bonded to it. Okay, now these alkanes here have got a homologous series, and we can find that homologous series by using that formula there, where N is the number of carbon atoms. So when you see N there, stands for carbon atoms. For example, let me just quickly show you how it works. For, say I come to butane with 4 carbon atoms. If I want to find the molecular formula of butane, I'll say then it's C4, N4 there, H2 into 4, because N is 4 carbon atoms plus 2. So what is this going to give me? It's going to give me C4 H2 times 4 is 8, 8 plus 2 is 10. That becomes the molecular formula of butane. So that's how you use the homologous series formula there. Next one, alkenes, same thing. This one has got double bonds between carbon atoms, and they are unsaturated, so they can still take more. Okay, it's a taxi again, not having a full number of passengers inside it. It can still stop for more passengers along the way. So this means they can still react with other substances to form new molecules. Okay, and now the homologous series for them is CnH2n. Okay, how does this work? Again, you can take an example of propene, 3 carbon atoms. It's going to be C3N3H2 into 3. And what do we get? This gives us C3H6. That will be the molecular formula of propene. Okay, now moving on. Here you would see I'm saying isomers here. What are isomers? Isomers are organic molecules with the same molecular formula but different structural formula. Okay, now what do we mean by this? Let me show you by a simple one here quickly, going back to butane. Butane has got, like I gave you here, this is the structure. Okay, but I can have again 4 carbon atoms like that. Okay, like that. So there I would have my hydrogen. Allow me to say that's my hydrogen there, and there's the bond. So that's what you have there, and you have the hydrogens around the carbon atoms down here. Okay, I still have 4 carbon atoms and 10 hydrogen atoms, but they are not arranged in this way. The structure is different. So the molecular formula here will be C4H10. The molecular formula here will be C4 CH10, but the structures are not the same. So these become what we call isomers. This one, the name there will be methyl propane. Okay, methyl propane because there is a structure of propane, but up here you have got a structure of a methane. So it's a methyl group because it doesn't have the fourth hydrogen there. Okay, so that's how isomers work. You need to be able to define them. Like I said here, to give a definition of what an isomer is, isomers are organic molecules with the same molecular formula but different structural formulae. Okay, all right. And here you've got alkynes, ethine, propyne, butane, pentane. And then the same thing here, homologous series, this one CnH2n minus 2. Okay, all right. So for propyne, for example, it should be 3H2 into 3 carbon atoms minus 2. So you've got 3H, 2 times 3, it's 6, 6 minus 2, it's 4. So that will be the molecular formula of propyne. See you in the next section.